So are you able to see my screen?
Yes, sir.
Okay, so that's good. Yeah. So as discussed, today we are going to solve some of the questions from the GATE question paper, which are from this particular course. And we are discussing the papers on GATE Geomatics Engineering paper, which highly align with this course which we have in Advanced Geomatics Engineering. So before that, just a quick clarification. Are any one of you is going to give a gate for this course or have already given the gate examination for this course? Okay, okay. If at all, if you plan to give, this will be very helpful to you. Otherwise, this will be helpful to you for your this particular course of Advanced Geomatics Engineering. So it will help you in this giving the examination, and we will revisit the topics which we have discussed since the week one in this course. So first question is like when we talk about any equipment or whether it's a radar or lidar or GPS, anything or any survey instrument also. There is two terms which we have to determine. Like when the all overall goal of geomatics engineering is to measure the earth. And when we measure something that comes the two different terms, whether like how accurate we are. So for that, there are two words which are defining as a accuracy and precision. So in this question, it is given that let's say two persons are doing a survey of any or they are measuring any location and they have taken multiple readings at just one location, and we consider it as a, let's say we have taken a multiple points using GPS. So we measured a line, let's say we measured a line between point A and point B using the GPS, and then that line we have measured for 6 times so that we get accurate. So here these are the two readings which are given. Just a minute, let others in. Okay, fine. Yeah. So the first readings were taken like 19.97, 20.02, 20.04, 19.98, 19.96, and 20.03. So distance, original distance was 20, and the readings which were taken using GPS, they give this result. And another were like 20.05, 20.07, like that. So you have to say that which of the survey done by P or Q, which one is accurate and which one is precise. So first, to do so, we have to get to know what is accuracy and precision. So for that, if we understand here on the right hand side, you can see one image. So here you can see that this is the point which you want to measure, let's say 20. And then if you get all the points near to the 20, then it becomes high accurate and high precision. On the other hand, if we see that whatever the readings which we are taking, they are same. Let's say we are getting 19.01, 19.02, 19.03, okay, 18.99. So everything is around 80 or 19. But it is far away from the original data point, which was around 20. So we can say here that precision is high because whatever the points which we are measuring, does not matter how many times we are measuring. All the results are coming similar only. But the accuracy of the work is not that much, and that's why we can say that the work is not accurate. Similarly, here if we see in this top left right panel, which shows the low precision and high accuracy. So here you can see the points are nearby to the center, but they are all of them are not near to each other, which means the precision with which we are doing the survey it's not good. So precision is low, whereas the accuracy is high because if you take the average of all these points, it will come near to the middle value. Similarly, when we talk about low precision and low accuracy, then the overall mean is also away from the center point and it is vary also from points to points. So now, based on this logic, you have to say, uh, given two situation, which one is correct, like which option is correct here. So here in our case, the actual distance is 20.
So option B.
Yes, option number B. So how you can say that B is correct? So let's analyze it. Let's say in B it is given that observed value of surveyor P are more precise. Okay, so here if we see the it's a 19.97,
Option C.
20.02.
So
Okay, so
option
it's
C, observed value of
okay. So you are saying option C. So we'll just analyze both the options.
yes,
Okay,
yes,
one by
observed value of P are more accurate and observed value of Q are more precise.
one. Yes. So let's analyze the both statement option B and C as we have confusion in between. Uh, Just
He is correct. C is correct.
okay. So C option is correct. Got the point? Because in B, if we see, like overall, it's near to that. But if you see, like more precision is in option Q. So C, observed values of surveyor P are more accurate because, like, if you take overall mean, then it will come near to 20. And Q is more precise because everything is coming near to 20 only. So the option number C is correct here. So let me just keep my marker on so that I can just a minute. So option C here. Okay, now the next question is like we have studied the electromagnetic spectrum in this course when we studied the remote sensing. And here we see that how it played a major role in defining the different types of remote sensing, whether it's a thermal, microwave, or visible or near infrared. So, given the different, like you have to classify or make this in order of increasing wavelength. So, which one will be the right option here? So, you have to show in which, if you go from left to right, the wavelength should increase.
So option D.
Option D, exactly. So option D is right. The gamma ray is having minimum wavelength, then we have X-ray, ultraviolet, then visible, infrared, microwave, and radio wave. The next question is when we want to define this relationship between frequency, wavelength, and the velocity of electromagnetic wave, which of the following relationship is true?
So option C.
Yes. So the speed of light, or we can see the c or velocity of electromagnetic wave, which is around 3 into 10 to the power 8 meter per second, is equal to mu, which is frequency, and the lambda is your wavelength. The next one is spectral signature of an object in a satellite image does not depend on. So I will just reiterate the concept again. The spectral signature, it means what? That let's say if you have any tree, okay, so what will happen that so many electromagnetic spectrums or you can say rays coming on this particular tree. So how this tree will emit the or reflect the different wavelength in different regions. So that is known as a spectral signature. So how we make this curve is, let's say on x-axis we plot the wavelength and on y-axis we plot the reflectance value. And then we see that in which particular wavelength the reflectance is high. Okay, so we make this kind of plot. So in terms of vegetation, we see that these peaks are coming in the near infrared region. So here on x-axis, we have wavelength, which we denote by lambda. And then here on y-axis, we have the reflectance value, which is in percentage. So which of the following option is correct here?
So swath weight of the satellite.
Yes.
So swath weight of the satellite.
Okay, the swath width is not dependent. Why? Because we see the swath width is how much area it can capture. Okay, the swath width when we define is, let's say this is your satellite, then how much area on ground it is covering. So whether it's this much area, so this is known as your SWAT width. Okay, so this one is known as your SWAT width. So depending on if whether your satellite is at which altitude it is, the SWAT width will vary depending on its coarser spatial resolution. So the SWAT width will not depend on the spectral signature, whereas how the other options are correct. So like they are not a part, because see, season of the year. So if you take the same data in the month of summer and in the month of after monsoon or post monsoon, okay, so what will happen, that vegetation will grow. So earlier there was no vegetation, now vegetation will came. So if you see the temporal dynamics, then it will increase the reflectance in the near infrared. So season will determine the spectral signature. The another thing is wavelength of electromagnetic spectrum. So that is already we have that on x-axis. So it will automatically is correlated with that spectral signature. And the option D is reflectance value from the object. So that also depends whether we have real grass or like just grass which we had artificial turf. So depending on which kind of objects we have, that will also determine the spectral signature. Because if we see the artificial turf, which is not actual grass, then the near infrared reflectance we will not get. So that's how we can differentiate between these two. So that's why the option D is also not correct. So swath width has no role in spectral signature, and other three has. Yeah. So the next question is on GPS. So we have studied a different kinds of code in GPS, whether it's a CA code, PY code, and then C2L codes and such kind of code, L1 code, L2C code. So which of the component of GPS signal that gets deciphered, like that we can receive by all the types of GPS receiver? So here you have to go and read about the theory in this GPS. So if you go, CA code is there, which can be deciphered by all the receivers, whereas PY code is limited, and then L1, L2C is also limited for particular receivers only, depending on the which wavelength they work on. The next one is for 3D positioning. When we want to collect the data of coordinates X, Y, Z on any point of the Earth, this global navigational satellite system requires how many number of satellites?
So four.
Yes, so correct answer here is 4. And this we discussed in detail during the class discussion also, that when we use the formulas or when we see the theory, like here the word written is 3D positioning. So it is associated with just three coordinate X, Y, and Z. But then why do we need a four satellite? Okay, so the reason is the signals which we are getting from GPS satellites, that has some time delay, and we have to correct, because the clocks which we are using in satellites which are there in atmosphere, they are having very high precision to the power of 10 to the minus 12 seconds. Whereas the clocks which we have in the GPS receivers, they have very less tempo resolution or precision, which will go around 10 to the power minus 3 to minus 4 seconds. And to avoid, to make a correction for this uh, time error, we need a one extra satellite, and that's why the time feature will also come into picture. And that's why for any 3D positioning, we need minimum 4 satellite, because X, Y, Z and time. So we have 4 variable and we need 4 unknowns. So basically 4 unknowns. So 4 unknowns, if you want to solve, you need 4 equations, and for that at least data from 4 satellites are necessary. The next question is basic objective of Navstar GPS is to provide service for. So what do we get from GPS?
So position, navigation, and timing.
Exactly. So we get the position, navigation, and timing. And here, someone of you will say that we also get the velocity as well. But the velocity will be the derived product. Why? Because we once we know the position and timing, we use those two features, and then we see what was the position at the time equal to t1, and what was the position at time equal to t2. and based on that we will get the velocity. So that one is a derived product, although we will get it from GPS, but that is a derived product, not the direct product. The next one is satellite image with 6-bit radiometric resolution has how many gray levels? So this is a question from remote
So
sensing.
64.
Yes, so this formula which is will use here is 2 to the power n. So 2 to the power 6 minus 1, like you can say from 0 to 2 to the power 6 minus 1. So basically we'll get from value from 0 to 63, which will make the ultimately 64. Okay, so here the correct answer is 64. Sorry. Now the next question is thermal infrared images are provided by which satellites? So this is some kind of a memory question, but if you want to answer this, it also has some kind of if you know the satellites, like in general also that we also discussed this in during videos also that what is the like which particular feature of that satellite has. So generally when we talk about Econos and QuickBirds, can anyone say why like those satellites are used for what? What is the main feature of those satellites?
Sir, for high resolution imagery.
Yes, exactly. So those two are useful for very high resolution imaging. Similarly, if we know the just Landsat series in like advancement, that how Landsat series has evolved. So we can see that MSS is like multispectral sensor. So it is name only suggesting multispectral. It like multiple spectral bands we are having, not the thermal bands. So option A is also deleted. Similarly, if we see B, sport and cartosat. So sport is for like also for high resolution, and then cartosat is we have Indian satellite which we have for elevation and the for DEM generation. So option B is also not correct. C you already told that it is for high resolution imagery. So only option which remains is D. And the one thing which you can also recognize quickly is Landsat TM. So the TM is thematic mapper, if you know the full form. So this satellites has infrared sensor within it, like sometimes band 10 and band 11, which is around in the thermal infrared sensor 3 to 10 micrometer. So the option number D is correct here. The next question is which of the following gets mitigated in DGPS positioning? So DGPS is differential global positioning system. And I will repeat the concepts of DGPS so that it will be easy for you. So why do we use DGPS is when we take the GPS reading, we get so many errors in our observable. Observable means the data which we are getting, like distance which we are getting from satellite to receiver. So when this ray or signal is coming from satellite to receiver, it will first the component of atmosphere. So there the errors because of the atmospheric cloak, error because of the orbital parameter will happen. Now when it will come to atmosphere, the errors will happen because of the troposphere, ionosphere and the other molecules which are present in the atmosphere. And then once it reaches to the surface, then the error will introduced from the nearby objects, which is known as a multipath error, top cycle sleep error. If some object will come inside the signal, then it will hamper and it will cause the cycle sleep. Then the depending on the topography also we will have error. So those will create the errors in the surface or near to the receiver. Now, why we use DGPS is we take the difference of two observable. So whatever error is common in both observable, that will get eliminated. So now if I am having my receiver, okay, at two different point in a on a land, and I am getting a data from same satellite. So which is the error which will be common for both receivers? And that will get resolved using DGPS. So anyone wants to answer this?
So multipath error.
Okay, so here see, think multipath error will happen at which level? At surface level, when the instrument is there. Okay, so if I am keeping my instrument somewhere where the lots of trees are there, and I'm keeping my another instrument where different types of buildings are there, and one instrument where I don't have anything. The land is very open. So multipath error will be high where I have urban and vegetation, which is because of the trees. But when I have barren land or nothing is present there, then I will directly get the signal from satellite. So that error will vary from location to location. And because of that, it is not same for all the receivers. So I cannot remove the multipath error using DGP. Got my
So
point?
atmospheric error.
Yes, atmospheric error. Because see, any like if you were at any point of time, the signals will come directly from the atmosphere. So the atmospheric error will be common for all the receivers. Similarly, the error which is coming in the clock, which is the satellite clock error. So that will be also same. So basically, most of the time, the error which is happening in the satellite part and error which are happening at the atmospheric part, that can be removed or minimized using DGPS. Rather the and whatever error, if it is happening at a surface level, whether is a multi-path, chalk antenna error or cycle sleep error, that we cannot remove using the DGPS. So the correct option here is atmospheric error. Okay. So if any point of time, if you have some question or if you need some more clarification, please let me know. I will explain in detail and we will revisit through the corresponding week's content also if you are not comfortable with the solution. Okay, so the next question is in GIS database, which type of attributes may be used to represent area? So in GIS, we have two types of data, raster data and vector data. And when we talk about vector data, we have so many attributes to it. Suppose I'm creating a polygons of different forest areas. So I can provide like how many trees are there within the forest area, what is the area of the forest, then what is the perimeter of the forest, then is it a national park or not? So yes or no. So that kind of different attributes are there. Now these attributes are defined in the four kind of measurements that we do. So these things we have not done in the class, but yeah, I mean you should know. So when we define the attributes, it might be a nominal, ordinal, interval, and ratio attributes. So we'll just discuss that what are the nominal, ordinal, and interval. Those are so whether it's qualitative or quantitative. So when we talk about nominal, then we just have name of the district or name of the forest or its category, whether it's a high dense, low dense, some kind of just category we have. As example, it's given that when we use land cover maps, we have forest, water, urban. So just a kind of land use land cover classes we have. Similarly, in soil type also, we have different types of soil which is classified as or as a labeled as a some number or some name. And we have some features names such as highway 101 or something like that. So here just values are there and different categories are there. When we go for the ordinal data, so ordinal data has two things, identity and magnitude. So along with the, let's say forest is there, so it will have two value. So just forest is there, then how the big is this? Or let's say we consider the data of reservoirs. So name of the reservoir or name of the dam will be termed as a nominal data. But when we add that name of the dam along with the its capacity to store volume, which will be like very large dam, medium dam, small dam. So that kind of order which we are giving, like large, medium, small, very large. So that kind of order which we are giving or magnitude which we are giving when we are having earthquake data, we classify it as a severe intensity, intense, normal, very moderate earthquake. So those is known as a ranks or orders. So if we have those two things, then it's known as a ordinal data. Then we have interval data. So interval data is also quantitative, but it is like if the temperature ranges between 0 to 10 degree, it's very cold. If it is between 10 to 20, it's just normally cold. Then 20 to 20, 30, it's normal. Then 30 to 40, it's high temperature, and more than 40, it's very high temperature. So when we have some value as a class, as well as some label and some identity, so then it is known as an interval data, where we are dividing our class as an interval. So we can measure, if we go from this class to this class, how much change is going to be happen on an average. Now the third one is a ratio data. So ratio data is just you have absolute value of something. When I am talking about temperature data, you exactly tell me that 25 degrees Celsius temperature, 30 degrees Celsius temperature. When I talk about dam, you directly tell me the volume of dam is 135 million cubic meter cube. Okay, so like that I have direct and direct value on which I can do the mathematical operations. So that is known as a ratio data. Okay, so is this concept clear for all of you, or any problem, any doubt in this concept?
No, sir, okay.
Okay, so now based on this, give me the answer of question number 23, which is like in GIS database, which type of attribute may be used to represent area?
Ratio.
Ratio.
Yes, so the answer is ratio. But here the question can come from any of the time. Let's say if I'm representing my, if on a GIS map, if I have temperature range, which is showed like in the given table, which is from 0 to 10, it's a cold, 10 to 20, it's very cold, then it will become the interval. If just temperature is given, then ratio, exact value. If range is given, then interval. Then we have nominal and ordinal. So get yourself comfortable with this terminology of attributes which we use in GIS. Now, when we use these attributes, we do have uncertainty in our data. So when we talk about attribute uncertainty, from where does it come from? So is it because of the error due to imprecision of coordinates registration? Is it because of the incorrect labeling and quantification of features? Is it because of the source document due to the cartographic bias? And is it because of the displacement of the object from its true location?
Error due to incorrect labeling and quantification
Exactly.
of features.
So when we talk about attributes, it's a kind of labeling only. So error which will come, it will become because of the labeling. So the other errors which are there, so that are the geographical error. Okay, so geographical error, if we will not do proper georeferencing, that the error in area, error in perimeter will come, which will create the issue in geometrical representation and mathematical representation or topological representation of the feature. Now the next question is, in GIS, reclassification is performed to, so reclassification is the
Classify a
name,
data layer using many attributes.
which option?
So classify a data layer using many attributes.
Okay, so first of all, tell me this operation is for classify a data layer using a many attributes. So no, that is wrong. So generally reclassification is useful when you have raster images. Okay, and reclassify means if you have some data and you want to reclassify it again and again. Basically, you want to convert your ratio attributes to interval attributes. So what I was saying again, I'm telling, let's say if you have the value of slope, which is like absolute
Yes, sir.
value of
It is
slope,
like
okay, from 0 degree, 5 degrees, 6 degree, like that. So I will classify it. If it is slope is less than 5 degree, the slope is gentle, or there is no slope, or the land is flat. If the slope value is 5 to 10 degree, the slope is gentle. Then 10 to 15, the slope is moderate. More than 15, the slope is high. And then if it is more than 20 or 25, it's a very high slope, extreme slope. So this is the kind
yes,
of
sir. So the data layer
reclassification.
into multiple data layers.
Okay, so the answer correct here is the group the range of values into a single value. If I am having 0 to 5, that I will make it into just one value, which is 1. 5 to 10 is equal to 2. 10 to 15 is equal to 3. So I am converting a multiple values in a given range. Okay, so now the next question is, how many number of cells of 30 meters spatial resolution DEM would be required to cover a 1 raised to 50,000 topographic map of Survey of India, assuming that 1 minute is equal to 1.85 kilometers. So here the thing is, let's say if I am having map, okay, I have this map which is made up of different pixels, and that pixel size is 30 meter by 30 meter. Okay, so let's say the size of one pixel is 30 by 30 meter. So they are asking like how many pixels I required if I want to create a map of 1 raised to 50,000. So how we can solve this thing is, let's say if we know the length or width of this map, we will divide it by the length of one pixel. Then we will get the total number of pixels in one line, and then we multiply it by, like if I get 5 pixels in this line column, then 5 pixels will be in this row. So 5 into 5, 25 it will become. Okay. So basically what I'm saying is, if the size of pixel is given to you is 30, okay, and now you know that the size of the image which you have is, let's say, it's like 90 meter by 90 meter. So size of this image is, let's say, 90 by 90 meter. So first of all, how many pixels will come into this? So 90 divided by size of one pixel. So 90 divided by 30. So how much? 3. Similarly, in this line also, 90 divided by size of one pixel, 30. So 30, 30, 30. So I will get 3 cross 3. So total 9 pixels here. Okay. So now in question, which is what thing is not given to us is, this is already given 30, but this length is not given to us. Okay, so this length we have to get from the question. So in question it is written that this is for 1 raised to 50,000 topographic map. So for that you should have some idea of Survey of India's map. So when Survey of India publishes a map, if the scale is written 1 raised to 50,000, then this dimension is around 15 degrees. So it's around 15 minutes. So this distance is 15 by 15 minutes. Okay. Now if this is 15 minutes, so first it's in minute and this one is in meter, 30 meter. So both units are different. Okay, so we have to convert minutes into meter so that we can do something like this 90 by 30. So for that, we know in question it is given that 1 minute is equal to 1.85 kilometer. So we will directly write, if 1 minute is equal to 1.85, if 1 minute is equal to 1.85 kilometer, then how much distance for 15 minutes? Okay, so you will first get the distance which will correspond to 15 minutes. So can anyone quickly do using their calculator how much we will get?
So 27.75.
Okay, so 27.75. So now the length of one side became 27.75, and divided by that we will do the size of one pixel, which is 30 meter. So that meter we will convert into kilometer, or else we will convert this kilometer into meter. So let's convert this kilometer into meter. So to convert that into kilometer to meter, we will multiply it with 1000 and we will divide it by 30. So can anyone tell me what is the answer for this?
925.
Exactly. So answer is 925. So 925 pixels in one line. So what will be in another line? Another 925. So total will be 925 into 925. So how much? So our answer will be 925 into 925. Are you getting me why we got, like, in one line we got 925, and same way on another line also 15 minutes was there. So here also we'll get 925 pixel. So if you want to calculate total number of pixels, you have to multiply it. As like here you can see in this line 3 pixels are there, in this line 3 pixels are there. So if you want to calculate total number of pixels, we have to multiply 3 into 3. So it will give you 9. So similarly here 925 into 925, what will be your answer?
The option E.
Option A, 855,625.
Excuse me, sir.
Okay. So
Yes,
here
me, sir.
the question was very easy, but the problem was that you should know the what is the dimension of Survey of India's topo sheet. If the given that if the Survey of India topo sheet is 1 raised to 50,000, the size of one tile will be 15 minutes by 15 minutes only. So when you are studying the geomatics
Excuse,
engineering or surveying or remote sensing, you should know that what products our government is providing from Survey of India. If they are saying that this is the scale, like there are the division which has made that first you have 1 degree by 1 degree map, then you will get the subset of it which will be around zero point 0.5 degree to zero point 0.5 degree, then there is a 0.25 degree. So like that there is a subsequent classification is there, and based on that the scale is specified.
excuse me, sir.
Yes.
Sir, can you please repeat the briefly the steps of this question? Actually, I have network issue today, so that's why the video was not clear and the audio also.
Okay, so I will repeat this question. Oh, is that your
So just
thing?
briefly explain. I will
Okay,
understand.
so here, see, it's a question is like the image is given to us and size of 1 pixel is given to us, and we want to find out how many pixels or how many pixels will be there in this given image or number of cells. So when we say that, let's say if given image, if it is 90 meter by 90 meter and size of 1 pixel is 30 meter, then if we want to find total number of pixels, what we will do, that we will divide 90 by 30. So we'll get 3. So 1, 2 and 3. So 30, 30, 30. So we'll do 90 divided by size of 1 pixel. So we'll get 3 pixels in this line and 3 pixels in this line. Then we do 3 into 3. Then we will get the total number of pixels. In the same question, it is given to us that size of pixel is 30 meter and this dimension is not given to us, this x and y dimension, so dimension, overall dimension of the image, but they have given one a statement that they are doing it for topographic map prepared by Survey of India at a scale of 1 raised to 50,000. So if you take a scale of 1 raised to 50,000, then this length is defined by 15 minutes by 15 minutes. So now first it is in minutes, so you have to convert that into linear unit from angular to linear unit. So you will convert 15 minutes into kilometer. And in question, it is given that 1 minute is equal to 1.85 kilometer. So 15 minute is how much? So you will convert that into kilometer, which will come around 27.75 kilometer. You will convert that into meter and divided it by to the 1 pixel size. And you will end
Yes,
up
sir.
with
Got it, sir. Got
925.
it.
Okay. So now the next question is on your remote sensing based question. So first thing is on true color composite and first false color composites. And we have discussed this in detail during our classes as well. So which of the following is it true for statement is correct in terms of true color and false color composite? So the option A is true color composite is produced by superimposing red band in red, green band in green, and blue in blue.
Sir, option A and C are correct. For
Okay.
triple composite, red, red, green, green, blue, blue, and for FCC, uh,
Option A and
recommend C, sir.
Option A and C. Yes. So the true color we put red in red, green in green, and blue in blue. And in false color, what we do in standard false color, okay, we put near infrared in red band and then we just shift the bands. So if RGB is there, green will go to red, uh, uh, like that. It's one shift will we have. So which corresponds to option number C. Now, and option number A also. Uh, Choose the correct statements in case of visual image interpretation. So this is the interpretation. Like in the one of the week, I have showed you an image of some of the buildings near to the island, and I asked you that how will you identify the different features from this image? So first, what we see is we see the size of the feature. Sorry, we see the color of that feature and the tone of that image, how it looks like basically. Then we try to analyze the size, shape, and texture. Like if different trees are there, then whether it's what is the texture of it. If soil and sand is there, then also we can identify it using the texture. Size also, like small
So
building,
option
high
A
building.
and option C are correct.
Yes. So like that, I will just explain this and then we will discuss. Okay. Yeah. So and then the how these pixels are assigned in the spatial system or in the image. So based on the pattern, height, shadow, size, and associations, we will get the different kinds of image interpretation. So here it's written that tone and color is a primary element. So that is true. While size, shape, and texture are secondary element. So that is also true. Size, shape, and texture are primary element while tone and color is secondary. So that is wrong. The first option is correct. Now the third one is texture refers to the frequency of tonal change in the area of image. So that is also true that tone or color is a primary element while pattern and associations are secondary. So pattern and associations are pattern is tertiary and the association is higher order. So that's why the option D is also wrong. So option A and C are correct option. Now the next question, the spatial resolution. So spatial resolution is defined by the size of your pixel. So spatial resolution of a satellite image P is 80 meter. And another satellite Q for spatial resolution is 20 meter. Now each of the image has 5112 by 5112 pixel size. Okay, so both have 512 by 512 pixel. So which of the following option is correct? Take your
So
time.
option C.
Option A
Option
and C. Option A and C.
option A and B.
So C.
A and C.
Minor
Okay.
details, minor details will be more clear in image Q, and image P will cover 4 times the area of image Q.
Okay. So first we'll see. Let's say the first image is 80 meter. Okay. So let's say we just make
So,
4 pixels.
uh, so it will
Okay.
cover, I think, 16 times the area of Q.
Yes, exactly. So option B is right. Okay. So let's see the P image. Let's say the size is 80 by 80. So let's say this is 80, this is 80, 80 and 80. Let's say we just assume the 4 pixels. And here also the size is same, but we are having 80. So 80 will divide by into 4. So how this will become is 80 and then it will be divided into further 20. So 1, 2, 3 and 4. Similarly in this also we'll see 1, 2, 3 and 4. So 1 pixel here is equivalent to 16 pixels here. Okay, so the area when we talk about the image P will cover 16 times the area of image Q, because see in every like number of pixels are same. Here also let's say 500 by 12 So what they are saying is number of pixels are same. So here 2 pixels are coming, and here we see, here let's say we take just 2 pixels. Okay, so this much is how much? 20, 20. So which will be 40 by 40. And here 2 pixels means 80 into 80. 80 into 80 plus 80. So it will become 160. Whereas here it is just 40. Okay. So the area which we'll cover using this P will be high. And how much high is 4 times or 16 times? 4 in one side, 4 in another side. So option B is correct. The second one is like if we have high resolution image, if the spatial resolution is very high, which is 20 meter, then we can see more details because the image will be more clear. Although it will show small area, but the details will be clear. So minor details will be more clear in image Q. Why? Because it has high spatial resolution compared to P. So option C is also right. Image P is higher resolution and image Q is lower resolution. So that is wrong. And they give you this option for confusion purpose, because when people see this numbers, if 80 doesn't mean it is having high resolution. The lower the value, higher the resolution. So how we define spatial resolution is ability to distinguish between two different objects. So if the pixel size will become reduced or small, then and then the resolution will become high or detailing will be high. So option D is wrong in that sense. Okay, so option B and C. Any doubt in this question?
No, sir.
Now the next question is which statement is or are correct for hyperspectral images?
So number of bands are more and bandwidth is narrow.
Yes. So this is quite simple questions. Anything else? So when you say what is right, also state that why other options are wrong, because uh, see, bandwidth is large and bandwidth is narrow. So anyone will be right, any one option will be right and one will be wrong. So if this one narrow is right, then this one will be wrong. And now we see the option number D. Bands are continuous. Contiguous means you can see here number of bands are more. Like you have multiple bands, like more than hundreds. And because of that, what will happen? These bands are continuous in nature. They are not like one band is in infrared and then one is in thermal infrared and one is in microwave. It is not like that. It is continuously placed across the electromagnetic spectrum. Because of that, option number D is also true here. It's a continuous bands because we have multiple bands. That's why it is a narrow, more, and continuous. Now we have next question. So satellite based navigation system, which is now Star GPS, which is by from US. Augment, and in that if we see the augmentation system. So which of the following
So
is
vast
the yes
wide augmentation system, vast,
VAS. So VAS is true. So
and
here see this
ignores.
is yeah ignores then. So VAS and ignores both are augmentation systems. See, this DGPS is differential global positioning system. So it is not a system. Okay, it's just a kind of method. But Gagan is our Indian augmentation system. Okay, so keep in mind about different satellites. Now the next one is about GPS. So now Star GPS consists of minimum 24 number of satellites. Is it true or false? So this is the GPS system from US. So how many satellites does it have? So we discussed this in theory as well.
Yes, sir, most GPS consists of minimum 24 satellites.
Yes, so that statement is correct. It has 24 satellites, minimum 24. Then the next one is precision of GPS positioning is being defined by its standard deviation. So that is also true. When I specify the coordinates, I see this is a error of deviation of 0.5 meter, or let's say we specify the standard deviation in terms of meter. So that is also true. Then we have DGPS method provides more accurate 3D position than relative static processing method. So that is not true, because relative static processing also we are taking the relative measurements. So it will not give the, it's not that the GPS will give the accurate result, both will give similar kind of accuracy. Then the next one is GPS observation from geodetic GPS receiver provides less accurate position than GPS code receiver. So that is opposite is true, that geodetic receivers provide more accurate position than code receivers. So that's why the B is incorrect. Now, next question. Identify the correct statement. For accurate GPS positioning, geometric dilution of precision, GDOP value, should be large as possible. So is it right or wrong?
So wrong.
No, it's wrong. So, okay, so GDOP value should be minimum. And GDOP is what? That if you have satellites in sky, let's say one satellite is here, one is here, one is here, and then one is here. The GDOP is the volume which it makes, and 1 upon that. So you make a diagonal like this, like kind of diamond kind of shape, connecting all the 4 satellites. And then this cone which you see, diamond kind of structure, you see the volume of it. So 1 divided by that volume. So if this volume is very high, then GDOP value will become very less. And it will give like satellites are distributed equally and away from each other. And because of that, we will get good positional accuracy. But in the same case, if satellites which are there on sky, if they are located nearby, then this volume will become less. And if it will become less, then the GDOP value will become high. And because of that, we will lose the positional accuracy. GDOP value should be minimum. The next is integer ambiguity is associated with the carrier frequency observations of GPS signal. So basically integer ambiguity is the number of times which we are measuring the frequency. So that is true. We use studied two observations, code pseudo range and like code and frequency pseudo range. So then this is the next one is GPS is one-way ranging system for user. So as a user, we only receive the data. We cannot send data to satellite. So that's why it's a one-way ranging system. But if we see for the control system, then it's a two-way. Control system can also receive the data from satellite, as well as it can give the data to the satellites as well. So if the option is for control user or control segment, then it's a two-way. But for users, it's just one way. Next one is during GPS surveying, initialization of rover receiver is required for
Stop and go method.
so stop go and relative kinematic methods. So you should go through these methods for more details. Now, when we have polygons or vector data in our GIS, then when we talk about the centroid, so what is the centroid of a polygon? Is it a geometric center of the polygon? Arithmetic mean position of all the vertices in the two coordinate directions? The point at which the cutout of polygon could be perfectly balanced at the tip of the pin and center of the polyline.
So option C.
C is true. Option A is also correct and option B is also correct. So this is multiple choice question, and when you are appearing for GATE or this kind of questions in NPTEL, just see your radio buttons whether it's just one answer or you can click the multiple options also. Okay, so depending on you will get to know whether it's a single choice question or multiple choice questions. So geometric center, like if we take square, then obviously the center of square is exactly its centroid, which will specify like option A and C both. And then arithmetic mean of all vertices. So if we take vertices mean, we will get the same point. Because if we take this vertices, we'll get this. This two late, we'll take this one. And this two mean, if we'll take, we'll get this position. this to mean it will take this position, and then we'll take mean of all four, then we'll get this location. So that is also true. Now the next question is the area of buffer of 50 meter around a proposed road of 1 kilometer straight. So this is a 1 kilometer road and there is a buffer. So buffer will become like this. So here also you have like this, and on side you have circular path. So GIS software will make a buffer like this, and this radius will be same of the distance of your buffer, which is around 50 meter. So in question it is asking us what is the area of this buffer. So area will be, how will you calculate
4
area?
pi r.
So first of all we'll calculate the area of this rectangle. So which will be around 50 into 1 kilometer. So 50 into 1000. So area of rectangle will become 50 into 50. So basically it will become 100 into 1000 because 1 kilometer. So 100 meter is its width. Which one? This is this one, height. 50 into 50 plus 50, which will become 100 into we have this length, which is 1000. Now we have to get the area of this circle. So when we combine these two circles, it will become a one circle. Semicircle, two semicircle will become make one circle. So area of circle will be pi r square. So you have the radius as 50. So you put value of pi, which is 3.14, and then the r value, which is around 50. So 50 square. So can anyone tell me the answer of this? Because see, in GATE or some examination, you have to write your answer as a text. Okay, so what they told us, you have to give the answer in integer only. Do not consider the fraction point afterward. So can anyone tell me the answer?
So 107850.
Exactly, it's correct. Okay, 107850. Now the next question is, select the incorrect statement. Scale of tilted photograph. So this is from the first week or second week of our this course, where we like learned about the aerial remote sensing. So scale of a tilted photograph is uniform throughout the extent. So
No,
in
sir,
tilted
it's wrong.
photograph, this is right or wrong?
So it is wrong.
It is wrong, obviously. So option A is correct. And here it's just written that select the incorrect statement. So only one is incorrect. So that's why this is the direct answer. But we'll just go through the other options also. The relief displacement of any point will be the radial distance from nadir point to the tilted photograph. So that is also true because when we have this relief, we see this relief displacement from the nadir point, how far it is, and based on that, we'll put the formulas and calculate the height of the object. The bisector of angle of tilt intersect to the tilt photograph at the point known as the isocenter. So that is the definition of isocenter. A line perpendicular to the principal line and passing through the isocenter is known as the axis of tilt, and we specify it as a terms of degree. So that is also a definition. Next one is select the correct statement or statements. The spheroid is a mathematical surface. So okay, so this is when we represents the any elevation data. So there are three kinds of surface which are being specified in the geomatics. The first one is a mathematical surface of the earth, which is in terms of ellipsoid. Then you have the depending on actual surface, which will be your topography. So depending on mountains or oceans, you have this kind of thing. And the third surface is known as a geoid. Geoid is the line of joining equal gravity. So that might be like this. So this is known as a geoid. This is known as a actual surface. So it is topographical level. And this is the ellipsoid, which is a mathematical surface. So I have not shown it properly, but when I talk about ellipsoid, it is just exactly the mathematical surface. There will be no annotations. So in considering that, which of the following option is correct? The first one is spheroid is the mathematical surface, so that is true. The geoid is the equipotential reference surface of the earth, so that is also true. True shape of earth is perfect spheroid. So obviously we know that that is not true. It's not exactly spheroid, some indentation is there. The WGS 84 datum varies from country to country, so that is wrong. It is common for every. When we talk about projected coordinate system or UTM zones, then it is a different from country to country, even like different from parts in India to India, like different parts of India, it's different. So the correct options are A and B. Now, depending on, I mean, all of you know latitude and longitude. Okay, so you have learned that in your basic geography. So which of the following statement is correct?
Sir, option A is correct.
Option A. Okay, here its
Yes, sir.
statements is written, so it's a multiple choice question.
I
So
think
when we
one is
specify this angle, longitude, because see, this is very critical definitions, and you should, all of you should remember this as not as a person who are studying in this course, but when you use maps, you should know what is latitude and longitude. So basically, when we talk about the longitude, it's a horizontal angle which it makes with the meridian and then reference meridian at given at any point. And when we talk about latitude, then it's a vertical angle which it makes with the equator to the given point through the plane which is perpendicular, sorry, parallel to the equator. So the option C is right. And the option D, latitude and longitude of a place are subjected to change with time. So that is not true. The time will change according to the latitude and longitude, but the latitude and longitude values will not change. Okay. So the option D is wrong in that case. Now let's see the next question. A parallax of point A on a pair of successively overlapping photograph is 73.22 and a micrometer reading for this parallax bar point A is 12.10. Similarly, the micrometer reading of parallax bar of point B is 9.65 mm. Then the parallax of B point is how much? So anyone know just how to solve this one? So there is a formula. I mean, this we discussed in the week 2 in during the classes. So parallax at any point is given as PA will be given by P mean. So minimum P displacement or the reference plus the readings which you take using the micrometer, which we'll say as A or B. So here parallax of point A is already given to us, which is 73.22. So here we will write 73.22. Now P mean that we don't know the reference. So we'll write it as X plus A is the parallax of or micrometer reading from A, which is given to us, which is 12.10. So first we will get the P minimum value. So that will become the X will become how much? Can anyone tell me? 73.22 minus 12.10.
61.12.
So 61.12. Now for B we will apply the same formula. So PB is equal to P mean plus B. And we have to find the PB. So we don't know PB. But we know now P mean. So P mean is 61.12 and B, which is the parallax of point B, which is also given to us, which is 9.65. So what will be the answer of PB?
70.77.
Exactly. So in GATE, they are allowing the option like answer between 70 to 71, and our answer is around like 70.77. So it is with between 70 to 71. So answer is 70.7. Now the next thing is the scale of an aerial photograph is 5 mm is equal to 100 meter. So in a photo, we have 100 meter is represented by 5 mm. Okay. The size of photograph is 23 by 23 centimeter. The longitudinal overlap is 65% and side lap is 20%. Then the number of required photographs to cover the area of 12.5 kilometer by 8 kilometer is how much? So how will you try to solve this question first? Like what should be your approach? So first of all, they asked us to cover an area of 12.5 kilometer by 8 kilometers. So I will draw that. Okay. So this is 12.5 5 kilometer side, and another side we have 8 kilometers. Okay. Now one photo is 23 by 23 centimeters. So when we take one photograph, it is 23 by 23 centimeter, but that is the dimension of photo. We don't know how much area it will cover on ground. So how we can do? We can do using the same thing which we did in the previous question, where we were given the photo in the size of 1 pixel and we can find out the stuff. So same thing we'll do here. So what 12.5 kilometers are there, and the one patch will cover how much area that we have to find. So it is given that one patch will cover the area in photo is 23 by 23 centimeter. But what is the area in real life? So for that, to convert the photographs into ground distance, we use the scale. So what scale is saying is that 5 mm in the photograph or 5 mm in image is represented by 100 meter on ground. So how much we have in photograph is 23 centimeter by 23 centimeter. So here we can see is 0.5 centimeter is equal to 100 meters. So how it like what is equivalent to 23 centimeter? So we will write like this: if 0.5 centimeter is represented by 100 meter on ground, 100 meter, and this 0.5 centimeter. So if I want to represent 23 centimeter, like because my photo size is 23 centimeter, then how much area it will cover in meter? So 23 into 100 divided by 0.5. So how much I will get? So 23,
4,600.
4,600. So roughly around 4.6 kilometer. Is that correct? 4,600 is equal to 4.6 kilometer. Any doubt till this point? Okay. So one photograph is of 4.6 kilometer by 4.6 kilometer. Now in this direction we have 12.5 kilometer area. So what we can do is just directly we can do 12.5 divided by 4.6. But is this correct?
So how we calculated this 4.6 meter?
So we just 4.6 kilometers. So what it is given in the first statement is scale of aerial photograph is 5 mm is equal to 100 meter. So what is the definition of scale is distance in photo is equivalent to distance on ground. So 5 mm in photograph is representing 100 mm in ground. So we'll convert this mm into centimeter because these dimensions are given in centimeter. So if 0.5 centimeter is equivalent to 100 meter on ground, what is the 23 centimeter on ground? So we just did this cross ridge 23 into 100 divided by 0.5. So we got the 4600 meter. 4600 meter we got. And that we converted into kilometer. So which is equivalent to 4.6 kilometer. So one photograph
So,
which we get using the satellite is a size of 4.6 kilometer by 4.6 kilometer. So if we divide 12.5 by 4.6, how much we will get?
So this
so
12.5,
2.7,
How much?
2.7.
2.79. So basically 3 image,
Yes, sir.
12.5 by 4.6. So basically 3 image, and generally we take one more image to make the, like, okay, so 3 image. But this is not true. Why? Because in question it is like when we do this survey, then we have to keep some overlap between images. So it is not like that one image is here and second image is here. Otherwise, and like it is second image is over here with the overlap of 65%. So basically we will get images like this. The first image, then I collected the second image, and the common part is 65% overlap. Then there is a third image, and this area which is coming in common in all the three images is known as a superlap. Then there is a fourth image. So we have to find this thing. For that, I mean, if you have remembered, we have discussed that formula that overall width which we required is ground distance into 1 minus your overlap. So if your overlap is 65%, then it will become 0.65. So what is the ground distance here? 12 point, sorry, our ground distance is 4.6. So 4.6 into like effective width which we will get is you have to remove the overlap. So whatever will remain, this much portion that we will consider. See, if I getting two images like this is the first image and this is the second image. Okay, so if I will remove the common area, what I will get with the remaining part? Now common area is 65%. So I will get the remaining of it, which will be around 35%. Okay, so 35%. So 0.6 4.6 into 0.35. So I will get the effective width of how much? 1.61. 4.6 into 0.35. So I will get 1.61 kilometer. So now instead of dividing the 12.5 by 4.6, I have to divide it by 1.6. So 12.5 divided by 1.6. And when I do this, I have to add the additional imagery to get this last image that we have discussed during our class. So that I have to add +1 for that to make the correction for the last image. So if you do this, you will get approximately 9 images. So that is for this direction. Now same thing we have to do for the other direction. So first of all, we have to find the effective width. So that is again ground width into 1 minus side overlap. So our side overlap is 20%. So 1 minus 0.2. So it will become 4.6 into 0.8, which will become 3.68. Okay, so now we will do this dimension. The length is 8. 8 divided by 3.68. And we have to correct it for the last image. So we have to add plus 1. Okay, so you will get around 4 images. So 9 images in the 12.5 kilometer direction and 4 images in this direction. So basically how much you will get? 9 into 4. So you will get total 36 images. So correct answer here is 36. So I recommend you to revisit this question again, do it by yourself, because this will cover all the concepts of your photogrammetry, and it will help you to prepare for either NPTEL exam or GATE exam, because it covers everything starting from scale to overlap to basic calculation.
Excuse me, sir.
Yes.
Sir, while we were calculating the scale, like
Mhm.
the distance, like this is 4.6 kilometer. So firstly, we calculate like there was 23 centimeter dimension of the photograph. So
Yes.
that's why we divided it by 0.5 centimeter,
Yes.
and we get 4.6 centimeter.
Hmm.
Then we multiplied it with the 100 meter. While we should so multiply it by not 100 meter. In fact, we should, don't we need to convert this 100 meter into centimeter, then multiply to 4.6.
Don't go into this kind of stuff. See, ask the basic question yourself. Don't do so many things. See, the first thing is scale of photograph is 5 mm is equal to 100 meter. Okay, and the dimension which is given to me is 23 centimeter, like dimension of photo. So if the scale is this much, how much area it will represent on ground? Because in ground, like, see, if 5 mm is equal to 100 meter, 23 centimeter is equivalent to how much? The simple question I have to ask. Now I cannot do this calculation if the units are different for each and everything, because here it's in 5 mm, it's in 100 meter, and this is in centimeter. So I have to convert everything into one unit, or at least everything on one side on same unit. So what I will do, I will convert this mm into centimeter so that it will become centimeter, and I can do directly interpolation. So I will, if I convert mm into centimeter, then it will become zero point 0.5 centimeter. So if zero point 0.5 centimeter on image represents 100 meter on ground, what will be the 23 centimeter on image will represent on ground? That clear?
So that's why my question, like we have to convert all the units into single unit.
Yes.
So why didn't we convert this 100 meter into centimeter?
That also you can do, but ultimately your answers, like, they ask you in kilometers, so that's why we converted into kilometer, because everything is in kilometer afterward. So that's why we thought, like, you can convert everything in centimeter also, that's also fine, but ultimately you have to convert into kilometer. So if we convert this 100 meter into centimeter, see, you will get like this, and the answer which you will get is will be added by two more zeros. So then this is in centimeter, that you will convert into kilometer. So centimeter to kilometer, you have to divide it by 5 times. So 1, 2, 3, 4, and 5. So ultimately you will get 4.6 kilometer only. Getting my point? You can convert everything on one side in same unit. So this we converted into centimeter, and this we kept into meter only. But doesn't matter. Like, you can convert everything into centimeter only and then do the calculation. You will end up in 4.6 kilometer or 46 like 4 lakh 60,000 centimeter, or else you can say it as a 4,600 meter also. It's just unit conversion. Okay, so you have to keep in mind the unit conversion.
Yes, sir. Got it, sir. Thank you.
Okay. Okay. So the next question is, so now I think in GATE questions, there are two parts. One is related to the survey and one is related to the computer science or the electronic science people who are who do the digital image processing part. So the questions which we like, the first section will be on the same, where they will check your basic knowledge of surveying and remote sensing or GIS, GPS. And in the another portion that will be very branch to branch. That whatever the questions which we solved on photogrammetry, GPS, that is like specifically for civil people. And then another part is for digital image processing part. So there you will see the questions on NDVI, image classification, image processing, band statistics that we have learned in our last digital image processing labs. So now we'll see some of those questions also. So the first one is the correlation coefficient between two bands of remote sensing data that would yield good classification is. So when we do classification, okay, we use that's a band 1, band 2, band 3 data for as a input data. But if classification like correlation between those two bands are near to 1, it means it will give us the redundant information. The same information if we are using, then it will not give us the proper accuracy, or it will not help us in classifying the different objects. That's why the correlation should be close to 0 rather than close to 1. If there is no correlation, it can give us the different information from the different bands. Is that clear?
Yes, sir.
Okay. So the next thing is in covariance matrix, the main diagonal shows. So this is just a direct thing. So if you construct the covariance matrix, it will show you the diagonal will show you the variance. Now choose the incorrect statement about the image segmentation in digital image processing. So segmentation divides an image into different regions. So that is already, image segmentation does not help in image
Option B
classification.
is the correct.
Segmentation helps in identifying objects or boundaries.
Sir, option
Segmentation,
B is correct.
yes, B is wrong because segmentation, if you are using, it will segment the different features which are similar, and if you are specifying the similar features, automatically it will help you in the classification. The next one is when the histogram of an image is non-Gaussian in nature, the type of linear contrast enhancement preferred to be used to. So Gaussian is means the histogram is like, generally if we take the histogram, then if it is like this, then it is known as a Gaussian histogram. But here it is saying as it's a non-Gaussian like this. Okay. So in that case, what we do is we take a part of a histogram and then do the analysis. That is known as a piecewise linear contrast stretching. So that is the answer here. Like if it is non-Gaussian, then we go with the piecewise. Like we divide our histogram into different parts and then do the contrast stretching. Now spinning of Earth, like how Earth spins as viewed from North Pole. So if you are at North Pole and if you see that how the Earth is spinning, okay, so how Earth spins from east to west or west to east, first of all.
Sir, west to east in anti-clockwise direction.
Yes, so option A is correct here. Now 71. In case of principal component analysis, the variance of single variable express the spread of its value about
Standard deviation, sir.
mean. Okay. So variance about mean. Standard deviation is like how much variance is there. Like if you do the covariance divided by. Okay, so it's a variance around mean, not the standard deviation. The next one is select the correct sequence for supervised classification of satellite image. So what are the steps associated in the for supervised classification?
So radiometric geometry correction, then trading, then classification, then accuracy search.
Okay, so we'll start with the 4, 3, sorry, 4, 2, 1, and then
4,
3.
2,
So
1.
option number B.
Yes, sir.
The next one is the sum of all the values in normalized histogram is equal to, so normalized is like we divided by total number of pixels. So it will end up
Sir,
in
1.
1. In Landsat 18, the digital number values of pixel in band 4, 5 and 10 is 80, 100 and 30. What would be the NDVI value for the same pixel? So band 10 is near infrared and band 5 will be red band.
So 0.11, 0.111.
0.11. So what will be the formula? 30.
So band 5 minus band 4 divided by band 5 plus band 4.
Okay. So we'll have 30, 100 minus 30 divided by 100 plus 30. Okay. So 100. Okay. So
So
this is very
100
straight.
minus 80 divided by 100 plus 80.
Yes. Okay, so I mean just go through it. It's a very simple. A minus B divided by A plus B. You just have to know the which band is corresponding to near infrared and which band corresponding to red. For a given set of radiance value, which amongst the following is unitless? So which of the following
So
statistics do not have unit?
kurtosis.
Yes, kurtosis is right, but skewness also do not have any unit. So kurtosis and skewness. So this is very basic statistics. Okay, you should know mean, median, variance, mode, skewness, kurtosis. Now match the following: low frequency filter, high frequency filter, Laplacian filter, and Sobel filter. So okay, you have to remember this thing. Okay, so option C and D is correct here. So basic filter you should keep in mind. Okay, the first one is low frequency that we know, like median mean filter, and then the fourth one is like Q, which is Sobel filter, like -1, -2, -1, 0, 0, 0, 1 to 1. And then second one, high frequency, is the one which is shown by the R. And then the third one is Laplacian, is the one which is shown by the S, last one. Band ratio in satellite image interpretation is applied to,
Enhance the spectral separation.
yes, so enhance the spectral separation and reduce the effect of topography. So option A and B both are correct. Next thing is given the uh, accuracy matrix, or we can see as a class accuracy matrix. What is the kappa coefficient, or what is the overall accuracy of the image? So this we know that 40 plus 25 plus 17 divided by total number of pixels, which is 48, 28, 24. So that will give you the overall accuracy, which will be around 82. And if you want to calculate kappa coefficient for this, then this I think we have revisited in the last to last classes. So I think we will not go into this and solve the other questions.
Yes.
So this is the formula: total number of pixels, which will be around, like class is 100, then sum of all the classes, which will be like 40, 25, and 17, and then this is the diagonal sum. So 48 into 45, 28 plus 28 into 35 plus 24 into 20. So that will give you this term, and then n is in 100. So you put everything and you will get the coefficient. Now the next question is the number of bytes requires to store 8-bit uncompressed image of 512 by 512 pixel is how much? So how many like bits is equal to 1 byte?
So two. Sorry.
Exactly. So 1 byte is equal to 8 bits. So 1 byte is equal to
Equal to
8
8 bits.
bits. Okay, so here 8 bit is given, so 8 bit means 1 byte only. So 1 byte is only coming. And how many pixels we have? 512 by 512. So total, find out how many total pixels are there. 512 by 512, how many? So if you do the multiplication of 512 by 512, it will become 262144 pixels. And
So
one
sir,
pixel,
so the 6.
262144. And every pixel will store 8 bit. It means 1 byte. So total number of pixel is equal to total number of bytes. Is it clear?
Yes, sir.
But in this question, if I will ask you that number of bytes required to store 16-bit uncompressed image for 512 by 512. So 16-bit means 2 byte. Okay. So it will become into 2 and it will become double. Now the next question is the minimum and maximum digital value of the image is 30 and 50. Okay. So it is like we have the data from 0 to 255. But
Excuse
the
me, sir.
minimum and maximum value are between 30 and 55. So this is 30 and this is 55. So your histogram is between this only, these two values only. Let's say somewhere like this. But you have this entire range from 0 to 5, 220 to 55. Okay. So now the question is if the DN value of a pixel is 35. So let's say the value is 35 somewhere here. Then what
So
will be the output DN value?
637.5 is the answer.
Yes.
So 637.5.
Okay. So the correct answer here is 51. Okay. And how it's like you have this formula, long formula, which is so what you have to do is you have to make this
So
30
to
to 0
get it
and
hidden value.
55 I say to 55. So like that you have to do a linear stretch and then this value will be transformed. So the new value for 35. So basically for that you have formula which is like I think we have
Yes, sir.
discussed
Yes,
this
sir. Yes,
35
sir.
minus
The
30
formula will
divided
be
by
35
55 minus
minus
30
30
exactly.
divided by uh,
Yes.
so
So
35 minus 30
35
divided by
minus
55
30 divided by maximum minus minimum which is 55 minus 30. So 55 minus 30 into range of your new series which is from 0 to 255. So multiply by this minus this. So 255 minus 0 plus the minimum value which is your this range is starting from 0. So you have to add 0 here. Okay. So if you solve this you will get around 51 answer. But now in this formula, here it is written like why we are taking just like how do we know that this range is from 0 to 255 only? Because they have told in question that the image is 8-bit data. And when we have 8-bit data, if you apply the radiometric resolution concept, then it will be 2 to the power 8. Okay, so from 0 to 255. But here, if the in question, if they change it to instead of 8-bit, if they do that, let's say 6-bit. Okay, so the answer will come different. Are you getting my point?
Yes, sir.
Okay, so if it is 6-bit, then it is like 0 to 64 or 63. Uh, okay, so in that case, 64 minus 0 will come and this value will decrease.
So,
Okay,
excuse me, sir.
yes,
So can you repeat the question number 82?
question number 82. Yes.
So, uh, in this, like, we have a 512 into 512 pixels size,
Hmm. Yes.
and number of bits in one byte is 8.
Hmm.
So, by how much we will divide this 262 144?
Hmm.
So, like, why we divided it by 16?
Why we divided by 16?
So, please repeat this question, like, what steps we
82 na?
followed in this.
82. 82. Question number 82 na?
Yes, sir.
Okay. So see, number of bytes required to store an 8-bit uncompressed image of size 5112 by 5112. So first of all, the image size is given to us. So in image, we have 512 pixels in row and 512 pixels in column. So how many total number of pixels will be there? 512 into 512. Is that fine?
Yes, sir.
Okay, so that will come around 262144. Is that fine?
Yes, sir.
Okay, now for one pixel, how many space do we need? So one pixel is storing 8-bit.
Yes, B.
Okay, is that clear?
Yes, sir.
So one pixel will store 8-bit. So how many, like how much space will be covered by 262144 pixels? So what we have to do is we have to multiply it by 8. But in that case, what we will get? We will get total number of bit. But we need answer in bytes. Okay, so we have to convert bit into bytes. So 8-bit is equivalent to how many bytes?
Sir, 1.
8. 8-bit is equivalent to 1 bit. So to this, our answer is in bit. To convert into byte, we have to divide it by 8. So this 8 will cancel out, and like every pixel, like one pixel have 1 byte because 8-bit is equivalent to 1 byte. So total number of pixel will be equivalent to total number of bytes. Is it clear now?
Yes, sir. Got it, sir. Yes, sir.
Okay,
Yes,
but
sir. Thank
here
you so
if
much.
in question, if it is written that 16-bit, okay, 16-bit uncompressed image, then for each pixel will store 2 bytes. So you have to multiply it by 2.
Yes, sir.
Okay. Okay. Now we'll go to the question number 84. So FOV, which is also known as a field of view. So field of view is like you are seeing like this. Okay. So field of view of a sensor placed at the nadir. Nadir is exactly at 90 degree. At a height of 6 kilometer. So this height is 6 kilometer. And you want to find out what is the swath width. Swath width means this much. This distance you have to find. So nadir is at 90-degree looking. So 90-degree looking means if this is 90, then one side angle will be become 45 degree. Okay. And if we apply the trigonometry here, that tan 45. So we applied here tan 45, which is equivalent to 1. Tan 45 degree is equivalent to 1. So tan theta is equal to the this side, which is your distance, which is x by 2, because we want to find ground height. So this entire thing is x. So this will become the x by 2. So x by 2 divided by height, which is 6. So this will become, if we solve this, then x will become 12. This 6 will go this side and then 2 will go multiply with it. So the ground distance will become 12 kilometer. Is that clear?
Yes, sir.
Okay. So, I mean, this is the questions from GATE 2022 paper or from Geomatics Engineering. You can relate like so many questions which we solved already in this course are the same questions are there. Okay. So similarly, you can check the papers of 2023, 2024 and 2025 and you will find some similar questions. I have compiled the questions from 2025 also, but I think because of the time limitations, we will not able to solve each and every one. But I mean, I will show you the which kind of questions are were asked in 2025 and how you can relate it with our course. So the theoretical question we will solve and numerical question I will just give you some hint how to solve from 2025 paper as well. So the first question is cloud appear white in optical visible spectral band of remote sensing image because of which scattering? So that is because of non-selective scattering. If absolute temperature of a body is doubled, then it would emit the how much radiation. So absolute temperature it's like how much radiation it will. So radiation is this is from the Stephen Boltzmann law, which specifies that it is proportional to T to the power 4. So if we double the temperature, then it will become 16 times. Okay, 2 to the power 4. So basically here the answer is non-selective. Here the answer is 16. If the emissivity of an object varies with wavelength, it is called as selectively radiant because it will radiate some portion only, not the everything. If it is emits everything, then it's known as a black body. If it emits at some portion, let's say zero point 0.8, then it becomes a gray body. And if it emits everything, then it's a fully reflective body. Or reflects. If reflect everything, if it does not emit or absorb anything, it becomes totally reflected. Now, in the context of global positioning system, the Sastanian model, so it is related to the tropospheric delay, which we had in GPS, which is coming from the tropospheric error. And this is for slant hydrostatic delay. Then we have this the context of global navigation GPS. Which of the following statement is correct? So here the correct answer is B. The real-time kinematic positioning and stop and go positioning are both kinetic methods. And the next one is which of the following statement is not correct in context of GIS? So raster data model makes the use of grid to cell that are organized into row and column. That is true. Vector data model represents the data in line point polygon. That is also true. Resampling is applied after geo-referencing of vector data sets. So we do not do geo-referencing of vector data. We do that for raster data. So that option is incorrect. And that's why this is our right answer. Topology is used in vector data to model to ensure the spatial integrity. So that is also true. And we have seen through that in the videos. Which of the following statement is not correct in context of shapefile? So shapefile is a vector data format which we use in QGIS or RGS or any GIS software, which is specified by .shp file, and like it is a topological data model. It's not a topological data model; it's like just vector data model. So it treats points as a pair of x and y. It's an example of georelation data model, and in this polygon can have duplicate arc and shared boundaries also. The table below, which is the attributes of an object or employee records, which attribute can be useful as a primary key or as a unique key. So unique key here, the employment ID will be as a unique key, like our roll number and all. We can use the employment ID as a unique ID. The geophysical variable that can be measured using GPS is seismic motion. Seismic motion means what is the movement of a earth, and that we can specify using the velocity. Like if we take the data at two different location, at same location at different time, it will give us the seismic motion. Then match the following. So this is the different satellites which measures the SAR data, synthetic aperture radar, and this is the electromagnetic spectrum for microwave remote sensing which we use. So here, if you see, I mean, if you just see the difference, then option B is correct here. So the NOVSAR is using this S band. DISAT, which is Indian satellite, which is using the C band. TERSAR is using the X band, and ALOS Pulsar is using the L band. Then this is the interpolation you have to do. So here the value of A is 120, B is 200, C is 250, and D is 120. So you have to find the value at X, which is 0.4 meter from this point and 0.5 meter from this point. So you have to do bilinear interpolation. So first you do for one axis, that here, let's say, yes. So I mean, we have solved this kind of question. So this is very easy. You have to just do the linear interpolation. So you can go ahead and do solve this thing. If you have some issues, you can mail me. Then this is the image, and we have to see that if we apply this mean filter, what is the value of P, Q, and R? So mean, if you want to take 5 plus 1 plus 3, so 6, 7, 8, 9. So 9 by 3, so it will become 3. So 3, 8 P for Q, 2 plus 3 plus 4. So 7, 8, 9. So that will also become 3. And for R, 3 plus 2 plus 1. So it will become 2. So 3, 3, 2. Then in GIS, a stream or river is represented by line and house are represented by polygon. The pollution in the stream is affected house within the distance of 500 meter on both sides. Which vector data analysis operation should be performed to identify the house affected by the pollution in the stream? So buffer and overlay. First we'll create a buffer of 500 meter around the river, and then we will see which are the which houses are intersecting with that buffer zone. So buffer and overlay are the operations we use here. The next one is if the radiant temperature of the black body is 360 and its emissivity is 0.3, the kinematic temperature of the body. So there is a formula which you multiply the emissivity into the body, you will get the kinematic temperature. Then the answer will be here is right answer is 408. So is like you will get 360 divided by 0.6. So there is a formula that you will apply and you will get. So after that, the next one is which of the following parameter does not affect the scale of the vertical aerial photograph? So this we have done so many times. The size of photograph, whether it's a smaller photo or larger photo, it will not affect the uh, scale. Then the next question is the select the correct statement in the context of release displacement. So in the vertical aerial photographs, so the relief displacement 0 is a principal point where it's like we are getting at an nadir view, irrespective of whether the point is above or below the datum. And if it is above the datum, we get more. If below datum, less. And like as we go high away from the principal point, the displacement will be more. So option A is correct here. It occurs radially from one of the image corners, no, from the principal point or the center. It has no effect on the appearance of the straight road and the undulating road. No, it will show the difference. Now the 23 centimeter square for format camera with a focal length of f is given, taking the vertical photograph of 60% end lamp. These photographs are viewed under a stereoscope with a base height ratio of 0.15 and the vertical exaggeration while stereoscoping viewing this photograph is, so you have to use the scale formula and then overlap formulas and this base to height ratio, and basically the multiplications you have to do and you will get this thing. Now, which one of the following image processing method employs the standard deviation? So standard deviation generally we use in the parallel classification. Which of the following is not a use to access the quality of remote sensing image? So quality we will get through the histogram, multivariate statistic and the univariate statistic, but we will not get it from the swath of the image. It doesn't, it will just give the what is the area it can cover. It will not give you anything about the quality, just the area it is covering. Which of the following technique is not used to atmospherically correct the satellite image? So radiative transfer model is useful for that. Histogram adjustment can be also useful for that. Image to image registration is for georeferencing application, not the atmospheric correction applications. And this matrix is given to us and we have to say that what is the following statement is correct. So band 3 provide, like, this is the correlation matrix. Okay. So if we see the correlation, like covariance is 1, and then the correct answer here will be like A and B. So band 3 provides, see band 3, if you see, it has very less correlation, and if it is having less correlation with the other bands, it will provide more information. As we have seen in the previous question also, it should be close to 0. And so option A is right. And there is a high redundancy in the band 2 and 4. So band 2 and 4, if we see, this redundancy is like too much, because if you see there is a high correlation. So that is also true. The standard deviation of all the band is equal. So that is also true. Sorry, standard deviation is different. Variance is same. The image cannot be classified using the band 1 and 3 only. So 1 and 3, if we see 1 and 3, it's 0.36, but cannot be classified. No, it can be classified because the correlation is less. So if we use band 1 and 3, we can classify the image because correlation is less, near to 0. It can classify using. So that's why that statement is incorrect. Now, histogram of a band of 3-bit satellite is given to us. So 3-bit, it means 2 to the power 3. So 0 to 8 value. And you can see the value with 0 are too much, like frequency with the pixel 0 is too much. So it means if there is no value, it means if it is 0, it means image is very dark, and if it is high here 7, the image is very bright. So first of all, there are more number of darker pixel in the image, then there are more brighter pixels in the image, so that is not correct actually. The mean digital number of the image is 1250, so that is also not 2 because it is going from 0 to 7 only. It may be predicted that approximately 40% of area in the image is covered by material with low spectral albedo, so that is also coming like true, and because of that we see the things in darker shades. Now, which of the following statement is or are correct regarding the cross track scanning sensor? So option B and D is there is no relief displacement along the direction of flight line, because if along the flight line we see just bottom, so that's not option B. And option D, linear feature have sigmoidal distribution. So B and D are correct here. So in case of normalized difference vegetation index, which of the following statement is correct? So option number A, B and D, it is functionally equivalent to simple ratio. It reduces the many forms of multivariate nodes. And option number D, it reduces the additive noise. No, it's sensitivity to kind of background variation. And the last one is simple interpolation problem, which we have seen. The coordinates are given, values are given, and you have to find it 5.3 and 3.7. So you just do the bilinear interpolation and get the value of this pixel. So I just very sorry, I just went very quickly, but I just want to give some brief like how the question will look like in the exams. So I just ran very fast. I will give these questions to all of you. You just go through it again. If you have some questions regarding any of the questions or any other questions from the all the weeks which we have discussed, then please drop a mail or write down that in the discussion section. I will try to answer your questions there only. So, like this is the some of the questions from the GATE examination from uh, 2022 and also from 2025. So yeah, like that said, we solved a lot of questions today. Some of it with the full solutions, and some of it just I give you just some brief for 2025 paper. So that's it for this course. Let's see you in the next if you are joining this course again. So thank you everyone for joining. Uh, Thank you.
Thank you,
Thank
sir.
you, sir.
See you and best of luck for your exams. Bye bye.
Excuse me, sir. Hello, sir.
Bye bye.